Today we were investigating area in order to develop an understanding of square units. Let us do a bit of revision, boys and girls. What is area? The amount of space enclosed by any two-dimensional shape is called its area. The word enclosed simply means to cover. In other words, the amount of space covered by any two-dimensional shape is called its area. We measure area using units called square units, which are based on the units we use for length. We can find the area of a polygon by dividing it into squares and counting the number of squares. Now, although we can use formulas, but I want to get you guys to the idea of dividing a polygon into squares and then counting the number of squares to determine the area. This will help you to get used to the type of questions you will come across in the investigation. The following, boys and girls, is a grass patch. It is 1 meter long and 1 meter wide, as you can see, and we call it a square meter. And this is how we write it. 1 m for meter and a baby 2 for square. So we read it 1 meter squared. The following is a vegetable garden. Now we need to calculate the following, its area actually, and how are we going to do this using the grass patches that we introduced previously. We are just going to fill it up with grass patches and then start counting the patches. So it will look something like this. We'll fill all the blank spaces with grass patches. So I'll put one here, one over there, one over there, one here, here, and there. And in total, we have to count the patches. So how many patches do we have? We have 6, and we know that they are all squared. So our area is 6 meters squared. On this slide, boys and girls, we have to order the shapes that we see from smallest to largest. And we also need to explain how we did that. So as you can see, the shapes are not the normal shapes we are used to. In other words, these are irregular shapes. Unlike our normal circle, triangle, square, these are irregular because we don't know what's their names. But we nonetheless have to order them from smallest to largest. I want you to think about how you are going to do this. How are you going to compare them? Because now there is not a specific formula that we can use, but there is something that they have in common. Can you see the triangular nut that is covering all of these shapes? That could help you. It means that these have the same triangle that they are covering, or rather the same size of triangles that they are covering. So you can use that as your clue to order these from smallest to largest. But you need to tell me, how did you do it? Same situation appears on this slide. This is still a series of irregular shapes, and we need to order these from smallest to largest. Now here we don't have triangles, but we have rather a square grid in which these shapes are placed on. So we can make use of this and find which one is small and which one is larger. So you can just simply count how many squares do the shapes cover. Just a clue. If a shape does not cover a complete square, then you do not count in that square, you disregard it. But if it covers more than half of the square, then you count it as a half. For an example, as you are trying to count the number of squares, you will realize that this area over here, this square is not completely covered, but more than half of it has been covered. So you will count that as a half. But if you look at this one, less than half of it has been covered. So you will disregard that, you will not count it. So you will count how many squares does each shape cover, and the number of squares will obviously help you to order the shapes from smallest to largest. Boys and girls, Rorisang has ordered these shapes from smallest to largest. He says that shape G covers about 7 triangles, which is true. Shape H covers about 8 squares, which is also true. And shape I covers about 28 squares. That's also true. So then he concludes that shape G is the smallest and shape I is the largest. Explain what he has done wrong. So boys and girls, when we order shapes, we need to make sure that they use the same units. Look at the grid of shape G, the triangular grid. Look at the grid for shape H, square grid, and look at the grid for shape I. It's also square, but the only difference is that it uses much smaller squares. So can you actually compare these shapes without using the same units? Explain what Rorisang has done wrong. So in terms of identifying the number of triangles and squares, he was correct. But to conclude which shape was the smallest and the largest, what mistake did he make? Remember that to compare shapes, we need to use the same units. If we are using squares, then let it be squares. If we are using triangles, then let it be triangles. But remember, the units have to be the same. So for your homework, boys and girls, the Mfuleni municipality wants to plant 12 trees in a new park. They are going to use 1 square meter of land for every tree. In how many different ways can they arrange these trees? So you need to draw a table to represent your answer. As an example, I have started with the table, so you will just need to extend it. So you will have number of rows, and you will also have number of trees in each row. So those will be now your arrangements. Then maybe you will say 2 rows, and if there's 2 rows, how many trees will there be in each row? Then you will give me all the possible arrangements that we can have, or the different ways in which these trees can be arranged. Next, the municipality needs to put fencing using wire netting around the area where he will plant the trees. How many meters of wire will he need for each of the following arrangements you have made in your previous answer? So let's say you have, I'm just going to do an example for 1 row where there is 12 trees in each row. Remember, he wants to plant 12, he wants to plant 12 trees, and you need to have different arrangements. So the first arrangement can be where you have 1 row, and in that 1 row you plant 12 trees. So let's see how much fencing will we need for 1 row, and you will continue with this example with your other arrangements. So now, boys and girls, this is how 1 row of 12 trees will look like, and we need to put our fencing around these 12 trees. So a visual representation will be the picture that I have, and then let's say you had to draw it on your picture. Now it would look like this. So this would be where 1 tree is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is where your 12 trees will be. This is the area which your 12 trees are covering. But this area needs to be covered by means of what? Fencing. So we need fencing all around this area. And we know this is 1 square meters, and the whole row will be a total of how many meters? 12. So we will need 12 meters of fencing this side, another 12 meters of fencing this side, as well as on these sides. So in other words, we have 1 times 2, because the 1 meters needs to be on 2 sides. So that's why we have 1 meters by 2, which equals 2 meters. And then we know that this is a total of 12 meters. So we need 2 times this. So 12 meters times 2, because we need to cover 2 sides. That equals a total of 24. So 2 meters plus 24 meters equals 26 meters. So in other words, we have covered the area around, we have put fencing around this area. So this side and this side need to be covered, and they are each 1 meter. So 1 meter plus 1 meter, 2 meters, or you can say 1 meter multiplied by 2, you will still get 2 meters. And here we know that since there are 12 trees which take a maximum of 1 meters each, so we will have 12 meters on this side of the trees, and 12 meters on this other side of the trees. So that makes it 12 times 2. So 2 meters plus 24 meters gives us a total of 26 meters. And that is what you do with all your other arrangements. When you are done with that, boys and girls, I want you to compare the area of your arrangements. So you will have, I don't know how many arrangements, but when you are done with all the arrangements you have, whether it's 3, 4, or 5 arrangements, I need you to compare the areas of those arrangements. In other words, I want you to look at the fencing of all your arrangements. Remember, the first fence was 26 meters long. 26 meters. Remember, that is not the area, it was the perimeter, so it is not squared. It is just 26 meters long. So I want you to look at the fencing of all your arrangements and then tell me which arrangement would be less expensive to fence. So there you do not need to calculate, but you can calculate. But I think it is just logical for you to look at them and tell which one do you think would be less expensive to fence. Boys and girls, thank you for your time. Please make sure that you do complete today's homework. It will really help you a great deal. Where you do not understand, make a note for me in the diary. First thing tomorrow morning, you ask me questions. It's important that you understand this work, and if you don't do it, you will not realize that you don't understand. So please, 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 I know the homework was too much today, but that was the last time you guys had so much homework. So please make sure that you complete it, and in tomorrow's session, you ask me questions. Thank you so much. You guys are so fantastic. Love you and see you tomorrow.